So sample space diagrams, a way of just showing all the possible outcomes. We looked a little bit at this the other day. Two six-sided dice are thrown. You can get a big sample space like that. And often drawing out that big sample space helps us calculate a bunch of probabilities. How many doubles are there? 6 out of 36. Count how many score less than 6. And scoring more than 8 or an even number. So you count all the ones more than 8s, which are your 9s, your 10s, your 11s, and your 12s. Then you go back and also count the even numbers you haven't done, which are your 8s, your 6s, your 4s, and your 2s. You could use your formula for that if you wanted to, doing the probability of 8 plus the probability of even number minus the overlap. So that would work as well. But when you have a chart like this, usually it's the fastest just to count it up. And you could count it up to be 24. You could also figure this one out by saying, well, that's a lot of numbers to count up. I think it's going to be quicker for me to count up all the odd numbers less than 8. And if I count up all the odd numbers less than 8, I've got my 6 7s and my 4 5s and my 2 3s. There's 12 of them. 36 minus 12 is 24 as well. So as far as drawing a sample space diagram, we can do that in a chart like we did last time with the dice. So if you want to do one heads and tails, one coin, and the die, you could create a chart and fill in that chart to list everything. And then find a probability that in a single experiment you obtain a head and a number less than 3. Well, if we look at our entire sample space, only those 2 red ones are the answers, so we would get 2 out of 12, or 1/6 as an answer. Another way to create a sample space is with a tree diagram. With a tree diagram, you have your first event followed by your second event. So my first event was the die, and there's 6 possibilities on that die. Then my second event was the coin, and off of each of those 6, it could be heads or tails. Heads or tails, heads or tails, heads or tails. And it gets very big very quickly. So often once our numbers get bigger, we don't write out the entire sample space. We just try to figure out ways to count how many would be in that sample space. And in this case, to figure out there's 12 would be easy using the fundamental counting principle. There are 6 ways on the dice, 2 on the coin. 6 times 2 is 12, so you know there's 12 in total.